The rules of limits. Below are some rules for limits which we will explore with examples later. First thing we want to look at is sum or difference. The limit of the sum or difference is equal to the sum or difference of the limits. So if we have the limit as x tends to some value of x, x0, for example, x tends to 3, of f of x plus g of x would be equal to the limit as f of x tends to the same value added to the limit of g of x as x tends to the same value. And the same is true for the minus. If it's f of x minus g of x, then it would be the limit of f of x take away the limit of g of x. So the limit of the sum is equal to the sum of the limits. So what about a product? The limit of the product is equal to the product of the individual limits. So if we look at the limit as x tends to a particular value of x of f of x multiplied by g of x, that's just equal to the limit of f of x approaching the same value of x multiplied by the limit of g of x approaching the same value of x. So the limit of the products is equal to the product of the limits. So with a quotient, the limit of the quotient is equal to the quotient of the limits, provided the limit of the denominator is not 0. Now we did see a situation where the denominator went to 0. So when that is the case, you just need to do further analysis. We saw an example of that in the intro. So the limit as x tends to some particular value of x of f of x divided by g of x is the quotient of the individual limits. And again, that applies provided that the limit of g of x, which is on the denominator, is not 0. If it is, you need to do some different analysis. And the final one is composition. The limit of the composition is equal to the composition of the limit. So if we have the limit as x tends to a particular value of x of f of g of x, then that's equal to f of the limit as x tends to x0 of g of x, provided f of g of x is continuous at x equals x0. This one probably isn't surprising if we think about this composition of functions, because that composition looks like this, in that f of g of x means that our value goes in here, comes out here, and then goes into f. So we end up with f of g of x at the end. So it's probably not surprising because the x0 here would go into the g just as it does here, and then into the f.